Hello everyone. Today we're going to look at stoichiometry. Stoichiometry is a process that allows us to calculate one value of how much a chemical we have or how much chemical we need if we know some other value. If we know some other chemical in our reaction, we can work out how much we're going to make. Right then, stoichiometry. Stoichiometry means using known information to calculate how much of a chemical is used, or maybe how much is produced, in a chemical reaction. There's four main steps in stoichiometry. The first one is to get the chemical equation for the reaction and to balance that equation. The second step is to calculate the number of moles for the chemical that we already have the information for. Then, the third step, we multiply this number by the molar ratio to give the number of moles. We use the number of moles to calculate the number that we actually need. Now that sounds like a lot of information, but it's much easier to understand if we do an example. Here's an example. What mass of aluminium is produced from reducing 500 grams of aluminium oxide to aluminium metal? Okay, so if you're going to make aluminium metal, that would be an important thing to know. The aluminium oxide here has a formula Al2O3. We haven't balanced the equation yet. We've got some aluminium here. We're going to produce twice as much aluminium as the number of moles of aluminium oxide that we use. Then we'll also produce some oxygen. We're going to make 1.5 moles of oxygen over this side. Okay, now our formula is, now our equation is balanced. We move to the next stage. Now, the next stage is to work out the number of moles of aluminium oxide, because we know we've got 5,000 grams, okay? They told us that at the beginning. There's 5,000 grams of aluminium oxide, so we know that one. Let's work out the number of moles. The number of moles is equal to the mass divided by the molar mass. And the mass is 5,000, so we put that number in, and we're going to divide it by the molar mass of aluminium oxide. Well, there's two aluminium atoms in the formula, and they each weigh 27, and there are 3 oxygens, and each of those weighs 16, and that's going to give us a number of 49. Put that in the calculator, you get 49. The next step is to multiply by the molar ratio. Now, over on the left-hand side here, there's an invisible 1 there, and we can see the 2 here. So that's the number that we're going to use to multiply by. We're going to go by, we put the 2 on the top there and the 1 over there. So that's the molar ratio. That's the ratio of the aluminium oxide to the aluminium. And we find that if we multiply that out, we get 98. 98 moles of aluminium is produced. Great, 98 moles of aluminium. But how many grams is that? Well, the number of moles is equal to the mass over the molar mass. So that means the mass is equal to the number of moles times the molar mass. We know the number of moles. The number of moles is 98. We just worked that out. We multiply that by the atomic mass of aluminium. That's 27. We get that from the periodic table. And we get an answer of 2,647 grams. Okay, so there's the answer, 2,647. If you want to be more precise, then you'll notice that we've only used 2 significant figures in our mass, our molecular mass here. So we should only quote it to 2 significant figures. We do that by writing 2.6 times 10 to the 3. That means 2.6 thousand grams, which is the correct number. Okay. Now, the next thing I've got for you is 3 examples. What I haven't done is balance these equations. I've done that on purpose because I want you to remember to always check to balance the equations. So Have a look at those, balance the equations. The first one says, what mass of ammonia is produced from reacting 5 grams of nitrogen with some hydrogen? Okay, how much ammonia is produced? Give it a shot. Let me know how you go. Email me the answer. Thanks. Bye.